Alright, welcome back. This is our final video on simplifying polynomial expressions. And we're just going to move quickly through examples here. We're on page 338 of the textbook. Page 338. And we're looking at question number 43. Question number 43 says quantity 4x to the negative 2 power y to the third power. I need to write this bigger. Quantity 4x to the negative 2 power y to the third power over x y to the negative fourth power, all this to the negative 2. Now reminding you again, we start with outer exponents last. We deal with outer exponents last. We start with what's on the inside first. Nothing cancels with the 4, so we leave this alone. Let's go ahead and just rewrite this. The 4 is left alone. Now deal with your x terms. Does the x on top move? Yes, it has a negative exponent, moves to the bottom. So we end up with the x to the negative 2 moves to the bottom, becomes x squared. Cross out the 4, cross out the x to the negative 2. The y cubed has a positive exponent, it stays. Y to the third. And the x on the bottom is x to the first power, it stays because it has a positive exponent, x to the first. And y to the negative 4 on the bottom, cross them out as you go. Y to the negative 4 on the bottom moves to the top, becomes y to the positive 4. And all of this to the negative 2 power on the outside. Now, we're not done with what's on the inside. Question, do things cancel? No. The y terms are both on top, the x terms are both on the bottom, so we just combine. This is quantity 4, and we have 3 y's times 4 more y's. When the bases match, we add the exponents. 3 plus 4 gives y to the 7th over x squared times x is x to the third. All this to the negative 2 power. And now we deal with the outer exponent. Are we done with what's on the inside? Yes. Now take the outer exponent. Since it's negative, it means flip it. So we flip the fraction on the inside. We get x to the third over 4y to the 7th. And now that we flipped it, we change the outer exponent to positive 2, and now square everything inside. If we square x cubed, we multiply the exponents. We get x to the 6th. And we square the 4. Square the 4 is 4 times 4 is 16. Square the y to the 7th. We multiply the exponents. This is y to the what? 14th power, and we are done. Okay? Number 44. Number 44 says quantity 5a to the negative 7th, b to the second power over ab to the negative 6th power, all this to the negative third power. We start with what's on the inside first. Nothing cancels with the 5, so we rewrite it. The 5 stays. The a to the negative 7th moves to the bottom, becomes a to the positive 7th. The b squared stays on top because the exponent is positive. The a on the bottom has a positive exponent of 1, so it stays. And b to the negative 6 moves to the top, becomes b to the positive 6, and the outer exponent is still negative 3. We have not dealt with the outer exponent yet. Now, we don't have anything to cancel. Instead, we combine the b terms. We end up with 5b to the 2 b's times 6 more b's is b to the 8th over 7 a's times 1 more a is a to the 8th. All this to the negative third power. Now that we've dealt with what's on the inside, we now deal with the outer exponent. Negative means flip it. So we're going to have a to the 8th over 5b to the 8th. Notice when we flip it, nothing changes. The a to the 8th moves to the top. The 5b to the 8th moves to the bottom. And the outer exponent becomes positive 3. Now we cube everything. Cube a to the 8th. When we have power of power, we multiply. We get a to the 24th. Cube the 5. This means 5 times 5 times 5, which is 5 times 5 is 25, times another 5 is 125. And then cube b to the 8th. We're multiplying the exponents, giving b to the 24th. And this is your final answer. So you've seen examples for 43 and 44. Now we're moving to question number 52. Let me grab another marker because this marker's going out. Okay, moving to question number 52. All right, very similar to what we've already done. However, we just get a little bit, these problems are just slightly more difficult. We're looking at 1/4. Well, let's do 53. Question number 53. This is 1/3. I'm sorry. No, question 52. Question 52 is 1/4 g squared multiplied by 8g plus 12h minus 16 gh squared. And what happens what happens when multiplication meets addition. Okay, when multiplication meets addition, distributive property applies. Now, if we look at what we're distributing, this is a monomial. Okay, notice g squared is on top. Okay, so 1/4 g squared is the same as g squared over 4. However, if I wrote 1/4 g to the negative 2, negative exponent means move to the bottom. This is the same as 1/4g squared, which would be a rational expression. So be careful. This is rational expression. This is monomial because we don't have variables in the denominator. So g squared over 4. You can just leave it as 1/4 g squared. You can leave it as 1/4 g squared and do 1/4 times 8. The fraction times a number should not be a hang-up at this point. 1/4 times 8. 8 divided by 4 is 2 times 1 is 2. G squared times g, we are adding the exponents, giving us g to the third. And now 1/4 times the 12, we do 12 divided by 4, which is what? 3. 3 times 1 is 3. And g squared times an h, well, we just glue it together. We put them in alphabetical order. G squared h. And then 1/4 times the 16. 1/4 times 16 is 16 divided by 4, which is 4 times 1 gives 4. Oh, positive times negative is negative 4. G squared times g, we're adding the exponents. This gives g to the third. And we have an h squared glued to the end. And this is your final, well, hold on. Is this the final answer? And we should always ask. Now we're done multiplying. What are we doing now? We are adding. Now when we add, something must match. Does anything match g cubed? No. Does anything match g squared h? No. We're looking for exact match. So since nothing matches, we're done. You can only combine under addition when things match. Okay, so number 50, let's do number 50, 55. Question number 55. It says a to the negative 3 b squared multiplied by, this is question 55 in the book, ba cubed. Notice the book gives the variables out of order. That's fine. We'll put them in order. B to the negative 1, a squared, plus b to the negative 2, a. Now, question, what are you looking at here? What is this called? Okay, what is this called? Notice we have a trinomial. Be careful. No. What is this called? This is 3 terms. This is 1 term. So you want to say monomial. If you say monomial, that's not correct. This is not a monomial. This is what? A cubed moves to the bottom. This is b squared over what? A cubed. Do we have variables in the denominator? Yes. So this is a rational expression. Also looking here, do we have negative exponents? Yes, we have negative exponents. This is not a trinomial. This is what? This is a rational expression. Okay, since we have variables in the denominator. But can we treat, is there any addition in this? No. This is all multiplication or division. So we can treat the rational expression the same as a monomial. Now, you can write it in this form or you can leave it in this form. The form that's written is easier. So the form given is easier to use. So b squared over a cubed is a rational expression. So you should see this as b squared over a to the third, where a to the third is on the bottom. The a to the negative 3 moves to the bottom, the exponent becomes positive. So this is a rational expression. What happens when multiplication meets addition? And when multiplication meets addition, distributive property applies. So now we're just going to multiply the a to the third times the a cubed. Now what is negative 3? We're adding exponents. What is negative 3 plus 3? Negative 3 plus 3 gives a to the 0. Now we have to discuss this for a minute. Okay, so 7 to the 0 is what? 7 to the 0 is 1. 8 to the 0 is what? 1. 123.2 to the 0 power is 1. Okay, so we say anything to the 0 power is 1 except what is 0 to the 0th? 0 to the 0th. 0 to the 0th is not 1. It is indeterminate. Now my question is, what is a to the 0? Okay, do you know what a is? No, I have not told you what a is. So is a to the 0 is 1 unless a is 0. So the question is if a were 7, let's just think. If a were 7, then we would have 7 to the 0, which is 1. If a is 8, we would have 8 to the 0, which is what? Which is 1. So if a is any number that's not 0, so if a is 7 or a is 8 or a is 123.2, then this would be 1. However, what if a is 0? Okay, this would be indeterminate. So we don't know what A is. We don't know what A is, but there's something key written on the top of your book. On page 338, if you look, at the very top it says simplify. It says simplify, and next to the word simplify it says what? Assume no variable is equal to 0. Why is it saying this? Why is it saying that assume no variable is equal to 0? It's saying to assume that whenever you have a variable like A, okay, the variable cannot be 0, meaning that we don't know what A is, but we definitely know what A is not. It's telling us in the book that there's an overall assumption. What is our overall assumption? Assume that what? And this is true for the rest of this class, and it's written on many of your SOL problems. Assume what? Variables are not what? Are not 0. Now, we don't know what A is, but we definitely know what A is not. A is not what? A is not 0. So we don't have this case. We don't have the indeterminate case. So it's a very important phrase that they say this. Assume that variables are not 0 means that whenever you have a variable to the 0 power, you're not ending up with 0 to the 0 or an indeterminate case. So we're assuming that A is not 0. We don't know what A is, but we know what it's not. Since A is not 0, A to the 0 is equal to what? A to the 0 is equal to 1. Do we write the 1? No, we can ignore it. So we don't write. You end up with negative 3 plus 3 gives A to the 0. B squared times B, we add the exponents. 2 plus 1 gives B to the third. And we can ignore the A to the 0 because the A to the 0 is the same as what? 1. So you're looking at 1B cubed, and we just write this as what? B cubed. So whenever you see A to the 0 or X to the 0, you can just ignore it because it's equal to what? It's equal to 1. Why? Because we're assuming that variables are not what? Assuming that variables are not 0. So A to the negative 3 times A cubed is A to the 0. We ignore it. B squared times B is B to the third. Now, next, we look at A to the negative 3B squared times B to the negative 1A squared. So A cubed times A squared, adding the exponents, negative 3 plus 2 gives what? A to the negative 1. And B squared times B to the negative 1, add 2 plus negative 1 gives 1, so we get B to the first. We don't have to write the 1, so we just get B. Now, A to the negative 3 times A. Okay, so negative 3 plus the assumed 1. Negative 3 plus 1 is what? A to the negative 2. Notice that I'm putting the variables in alphabetical order. And then B squared times B to the negative 2 is B to the what? 2 plus negative 2 is B to the 0. Do we write B to the 0? No. B to the 0 is assumed to be 1 because we assume that our variables are not 0. We don't know what B is, but we definitely know that B is not 0. So if B is not 0, B is another number like 7 or 8. 7 to the 0 is 1. 8 to the 0 is 1. So we can ignore this and say that B to the 0 is equal to 1. Now my question is this a final answer? No. Okay, we're done multiplying. We're now adding. Does anything match? Does B cubed match anything? No. Does B? No. Nothing matches. Nothing matches. So you can't add anything. But is this a final answer? No, it's not. Why is it not a final answer? Because you have what? You have negative exponents. Now, negative exponents being moved from top to bottom. So I want you to pause the video and attempt. Pause the video and attempt to finish this problem. Okay, now, if you wrote this, B to the third plus, I see a lot of students do this, plus B over, I don't know, I get all kinds of stuff, plus 1 over A times, or A plus, I don't even know what to write here, A squared. This is completely wrong, completely wrong. Okay, don't make this mistake, don't make this mistake. Do negative exponents affect, does the A to the negative 2 move to the bottom of the whole thing? No. Remember, addition separates terms. Addition breaks things apart. Think of addition as a fence. Addition is a fence that divides properties. This is a property, this is a property in terms of a farm. This is a farmer's farm, this is another farm, and this is the business down the street. But each of these properties has a no trespassing sign. You cannot trespass. So we think of a product. Okay, B cubed is a product, A to the negative 1B is a product, and A squared is a product. Negative exponents only shift within their own product. Up to this point, you've looked at this. If I write x to the negative 2 times y to the third over z squared, do you see any addition in this? No. Everything at the beginning of this lesson and in previous lessons Anytime you had negative exponents, you move them to the bottom. Why? Because there's no addition. Everything is what? Everything is multiplication. So x to the negative 2 moves to the bottom. You get y cubed over what? X squared, z squared. So negative exponents shift within a product, but they don't shift over addition. Addition separates the products. So we look at each one of these as individual products. So you have 3 products on the board. 1, 2, 3. And each negative exponent shifts only within its own product. So b cubed stays the same. We have b cubed. Now the a to the negative 1 moves only within its own product. So we have plus. The addition separates things. So we have the b stays on top, and the a to the negative 1 moves to the bottom. We just have a. So b over a plus, and a to the negative 2 is 1 over a squared. Notice that the negative exponent shifts only within its own product. So it moves to the bottom of its own product. The a to the negative 1 moves where? It moves to the bottom of its own product. So this is your correct answer. The final answer is b cubed plus b over a plus 1 over a squared. Now, next example. This is just like a quiz question. So let's look at this example. 1/3, or make negative 1/3, the fraction in parentheses, x to the negative 2, y to the negative 1 multiplied by 9x squared, 9x squared minus 8xy plus 12y squared. Okay, so this example. Now, and this is just like a quiz question in excess. Question, what are you looking at here? What are you looking at here? Is this a monomial? Well, you don't see any additions. You want to say monomial, but this is not a monomial. This is what? This is rational expression. This is negative 1 on top over what's on the bottom? Well, you have a 3 on the bottom. What else is on the bottom? The x to the negative 2 is on the bottom, becoming what? X to the positive 2. And y to the negative 1 moves to the bottom, becomes what? Y to the first. You're actually looking at a rational expression. When you see x to the negative 2, y to the negative 1, these are actually sitting on the bottom with positive exponents. So this is a rational expression because you have variables in the denominator. So instead of rewriting this as a rational expression, leave it in this form, and when multiplication meets addition, distributive property applies. We're just going to distribute. Negative 1/3 times 9. Okay, 9 divided by 3 is 3 times 1 is negative 1. We just write this as negative. I'm sorry. 9 divided by 3 is 3. 3 times negative 1 is negative 3. I'm sorry. X to the negative 2 times x squared. We add the exponents. Negative 2 plus 2 gives what? X to the 0. Do we write x to the 0? No. We assume that our variables are not 0. X to the 0 is assumed to be what? It's assumed to be 1, because we know that x is not 0 because of our assumption. Now, y to the negative 1 just glues to the end, so we get y to the what? Negative 1 power. Now, negative 1/3 times negative 8. Be careful, negative times negative is positive. And since we can't do 8 divided by 3, we think of this as 8 over 1. We multiply the 8 times the top and the 1 by the bottom. 8 times 1 is 8. 1 times 3 is 3. So we get 8/3. Now, x to the negative 2 times x to the first. Negative 2 plus 1 is negative 1, so we get x to the negative 1 power. Y to the negative 1 times y to the first. Negative 1 plus 1 is 0, so we get y to the 0. And we don't know what y is, but we definitely know that y is not 0. Since y is not 0, it's a different number. Some other number to the 0 power is 1. And we can assume that y to the 0 power is equal to 1. We can just ignore it. Okay? So we don't write to the 0 power. We just ignore this. Negative 1/3 times 12. Negative times positive is negative. 12 divided by 3 is 4. 4 times 1 is 4. X to the negative 2 glues to the end. And y to the negative 1 times y squared. Negative 1 plus 2 is 1, so we get y to the first power. We don't write the 1. And now, is this a final answer? No. We have to get rid of our negative exponents. Remember that negative exponents shift within their own product. You have 3 products on the board. Okay, so negative exponents shift within their own product. The y to the negative 1 will move where? To the bottom. Does the negative 3 move? No. This is a negative number. It stays on top. So negative 3 over y to the negative 1 moves to the bottom, becomes y. X to the negative 1 also moves to the bottom, hanging out with the 3. So we get plus 8 on top over what? 3x to the first on the bottom. Minus, and now this x to the negative 2 moves to the bottom. We have 4, and what else is on top? Y over x to the negative 2 moves to the bottom, becomes x squared. And this is our final answer because when we're adding, something must match. None of these match. We're done. Okay, so this is your final answer. A couple more questions and we're done with this video. Let's see. Number 56 in your book. We're going to do 57. Number 57 is quantity n squared minus 7 multiplied by quantity 2n cubed plus 4. Now yesterday, or in the last video, I said when multiplication meets addition, we use what? Distributive property. And you did this. You did, well, let's show an example. We're going to use a different process today. We're going to use a trick that's going to save us some time. Okay, this trick is called FOIL. Let's look at x plus 2 multiplied by quantity x plus 3. So yesterday we looked at multiplication, distribute over addition. We take what? The binomial and distribute. We end up with x, notice quantity x plus 2 times x, then quantity x plus 2 times 3, quantity x plus 2 times x, we put the x first, and then quantity x plus 2. X plus 2 times x is the same as x times x plus 2. Then we take the quantity x plus 2 multiplied by the 3. Quantity x plus 2 times 3 is the same as 3 times quantity x plus 2. Now, we now take the x and distribute, so we get x times x is x squared, x times 2 is 2x. And take the 3 and distribute, 3 times x is what? 3x, 3 times 2 is 6, and add the 2x and 3x, we get x squared plus what? 5x plus 6, and we are done. But we can save a lot of time. We're going to use a trick called FOIL. Okay, now you've probably heard of this in previous classes, but I don't like the acronym FOIL. I'm just going to show you what to do. X plus 2 times quantity x plus 3. This is so much faster, but it's a trick. But I want you guys to understand that this trick of FOIL is a way to bypass the distributive property. It's a way to get to an answer quickly, but it ignores the distributive property. We're not going to distribute the binomial now. Tonight, I want you doing this. And then for the rest of this course, this is what we're going to do. Take the first term, this is much faster, take the first term x and multiply by both. So we're going to take x times the x and get x squared, x times the 3 and get 3x. Now take the second term, which is 2, and multiply by both. So 2 times x is what? 2x, and 2 times 3 gets 6. And we finally get x squared plus 2x plus 3x is 5x plus 6. And you're done. So you see that this is much faster. This saves a step. Okay, so this saves time. So instead of using distributive property here, now it's not wrong to use distributive property. Distributive property is technically correct. But I want you guys saving time. And I also want you to practice the foiling method. So on the next quiz, I'm going to be emphasizing that you FOIL. Okay, so the requirements on the next quiz are that you FOIL instead of using distributive properties. So practice this technique. Take the first term and multiply by both. This is a binomial times a binomial. Take the first term, multiply by both. We get n squared times n cubed, 2n cubed. We add the exponents. We get 2n to the what? 5th. Now take the n squared times the 4. We get what? Plus 4n squared. And now take the negative 7 and multiply by both. Okay, so negative 7 times 2n cubed, negative 7 times 2 is negative 14. And we have an n cubed attached to the end. And negative 7 times 4 is negative 28. And we are done multiplying. Now we are adding. Okay, so now that we're adding, we check. Does anything match n to the 5th? No. Does anything match n squared? No. Does anything match n cubed? No. So we are done. Nothing matches, so you're done. So when you're adding, something must match. You're finished. Okay, so let's look at another example. This is like your homework question number 58, but we're going to do 59. So looking at question number 59, and this is probably the most important question of all. Okay, quantity 4n minus 5 to the 3rd power. Question. Do exponents distribute over addition? Do exponents distribute over addition? Is this equal to 4n quantity cubed minus 5 quantity cubed? No. This is the worst mistake you can make in Algebra 2. Exponents do not distribute over addition. We cannot cube the 4 and cube the 5. Reminding you, xy, here, let me show you. When do they? Okay, so exponents distribute over multiplication. X times y to the 3rd, x times y here. X times y to the 3rd is what? X to the 3rd, y to the 3rd. Do exponents distribute over the operation multiplication? Yes, they do. However, x plus y to the 3rd, do exponents distribute over addition? No. This is not equal to x to the third plus y to the third. This is the worst mistake you can make in Algebra 2. Rather, what does x plus y to the third mean? X plus y to the third means x plus y times what? X plus y times x plus y, and this is a monstrous problem. Okay, so you have to actually FOIL. This is a lot more work than just simply cubing the x and cubing the y. So can we cube the 4n and cube the negative 5? Absolutely not. So we have quantity 4n minus 5 to the third power means what? This means 4n minus 5 multiplied by 4n minus 5 multiplied by 4n minus 5, and we have to FOIL. Okay, so I want you to use distributive property. When multiplication meets addition, this is distributive property. We're going to use a trick FOIL. I want you to ignore the third one. Just focus on the first two. So we're going to take the first two, take the first term, multiply by both. 4n times 4n is 16n squared. 4n times your negative 5 is negative 20n. And now, negative 5 times 4n is negative. Take the second term and multiply by both. Negative 5 times 4n is negative 20n. And negative 5 times negative 5 is positive 25. Now, do we just lose this third term? No, it's still hanging around. So I want you to put parentheses and don't just ignore this third term. Write it. 4n minus 5. It's still hanging out here. We just haven't worked with it yet. Now, we're not done with what's on the inside. We're done multiplying. We now have to do what? We now have to add. Does anything match n squared? No. Does anything match your n term? Yes. What matches doesn't change. So let's go ahead and write the 16n squared. This does not change. Cross it out. The n matches the n. The n will not change. Negative 20 minus 20. Since the signs are the same, we add. This is negative 40n. Cross these out. And we have plus 25 on the n. And this is now multiplied by what? Quantity 4n minus 5. So we're done multiplying the first two. And this is the result. Now we have to take this trinomial and multiply by this binomial. Okay, same thing. We're going to use the trick. Okay, take the first term and multiply by both. Okay, so 16n squared times 4n. 16 times 4 is 64. N squared times n is n to the third. Okay, now take the 16n squared times the negative 5. 16 times negative 5 is negative 80. And we have an n squared attached to the end. Okay, so now take your second term, negative 40, and multiply by both. Negative 40n times 4n is negative 160. 40 times 4 is 160. N times n is n squared. And negative 40n times negative 5, negative 40 times negative 5 is positive 200. And now take your last term, 25, and multiply by both. 25 times 4 is 100, so we have 100n. And 25 times negative 5 is negative 125. And now we're done multiplying, now we're adding. Does anything match n cubed? No. So we write 64n to the third. Cross it out. Does anything match n squared? Yes, we have n squared here. So the n squared does not change because we're adding negative 80 minus 160 since the signs are the same. Add, this is negative 240. Negative 240 n squared. Cross these out. Now, the n terms match, so the n will not change. 200 plus 100 is 300n. Okay, cross these out, and then we have a minus 125 on the end. And this is fully simplified. So what you've done is you've taken this quantity 4n minus 5 cubed, written it 3 times, FOILed the first two, got a result, took the result, multiplied it by the third one. So you see, is this much more work than simply cubing the 4? Is this much more work than simply cubing the 4 and cubing the 5? Cubing 4, cubing 5, no. We are not just, exponents do not distribute over addition. This is wrong. Instead, you write it how many times? You write it 3 times and FOIL, and that concludes this video. Good luck on your homework.